All right, hey everyone, we're going to be talking about a bunch of triangle theorems. So what we're going to start with first is the triangle inequality theorem. So what that is saying is the sum of the lengths of any two sides are greater than the length of the third side. So the two sides has to be greater than the third side. So just remember the little shortcut is the sum of the two small sides need to be bigger than the largest side. So I'm going to do an example and then you can do the rest. These are all pretty easy. You're just checking to make sure that everything works out as it needs to. So let's go ahead, let's start with this. So let's do the sum of the two small sides. Well, the two small sides are your 5 and 7, and I'll zoom in for you. And 5 plus 7 is 12. Well, is 12 bigger than 9? Because that's the largest side. If your answer is yes, then you're good to go. So let's try this one, 381. So let's pick the two smallest sides and add those together. So 3 plus 1 is 4. And we want to know, is 4 greater than 8? Well, that's false. No. So we know, therefore, this makes a triangle. This first one here, this makes a triangle because this is true. This is not a triangle because this is false. All right, you're going to complete that one and that one. And then now we're going to talk about finding the range. So to find the range, you're just finding how much the length is between the two values. And so it's pretty easy when you think about this. It says here that the third side has to be larger than the other two sides. So you're basically going to subtract one way. And then the third side has to be smaller than the other two sides, so you're going to add. So if you want to find out the larger, you're going to subtract them to find the units between. And then you want smaller, you're going to add them together. And then you want to write it as a compound inequality. A compound inequality is where you have a number here, you have a variable with your inequality signs in the middle, and you have another number there. So your variable needs to be between those values. So let's go ahead, let's try this first one. So if you were to add 8 plus 3, that would be 3 plus 8, so that's 11. And I'm kind of doing this backwards. And then if you were to subtract, so this is when you added. And then for subtract, you would get 5. You put your variable in the middle, and then you make an inequality. So what you're saying here is that your amount for your side has to be 5 has to be less than x, and then x has to be less than 11. So it needs to be between these two values. All right, so pretty easy. I'm going to have you go ahead and finish the other two. So you're going to do this guy, and you're going to do that guy. All right, we're kind of moving and grooving. Exterior angle theorem. So when you look up at this first one, I've already labeled the angles for you. For exterior angle theorem, exterior means outside. So we're going to talk about this. It says in figure 1, the measure of angle 1, that's how you say that, measure of angle 1 is 132. So I've got that right here. And then the measure of angle 2 is 60. I've got that right here. And the measure of angle 3 is 72, and that's right here. So now, what we're going to do is we're going to follow directions. We're going to combine as needed. So it says here, if you were to take the measure of angle 1, which is 132 degrees, and take the measure of CAB. So CAB, I'm going to highlight this for you. All right, let's see. CAB. So you're looking at this angle right here. So the measure of CAB, well, we don't know what that one is, but we can find that out because all you have to do is know that this guy, where are we? 132, well, we don't know what that is, but that's okay because doesn't it make a straight line? So if it makes a straight line, both of these together make a straight line, you know it's going to be 180. So we could easily figure out the measurement of CAB if we needed to. All right, so now let's look at the second for part B. The measure of angle 2 which is right here, 60, plus the measure of angle 3, plus CAB, which is this angle right here. Well, it's the inside of a triangle, so we know that has to be equal to 180 also, even though we don't know what this inside angle is. So if you notice, they're both 180 degrees. So you could figure out this guy by going 132 or 180 minus 132 because it forms a straight line. Or you can find it this way by doing the three angles together, which will equal 180. So if I were to go ahead and say the measure of angle 1, which is this outside angle of 132, and M2 and M3 right here, what I would notice is that the measure or angle 1 is equal to the sum of angle 2 and angle 3. And that's basically your exterior angle theorem. It's the shortcut. Instead of finding this angle, it's the shortcut for finding whatever your missing angle is there. Okay? So exterior angle theorem says the measure of the exterior angle of the triangle is equal to the sum of the two opposite interior angles. So sometimes you'll see it called remote interior, but same thing. Instead of opposite interior, it might also be remote interior, either or. All right, so let's use some pretty colors. This is saying that angle D is equal to the sum of angle A plus B. All right, so your exterior angle is equal to the sum of A plus B, A plus B. All right, so I'm going to do an example for you, then I'm going to let you figure out how to do number 2. So for this guy, we know this is your exterior angle, and then these are your two opposite interior or remote interiors. So we're going to say that X, because that's your exterior angle, is going to be equal to the two remote interior. So therefore, X is equal to 149 degrees, and that's your answer. So I want you to go ahead, you're going to try this one, and we're going to do this one. All right, same process, but they just twisted it for you. This is still your exterior angle here, so it's 11x plus 2, and that's going to be equal to this guy plus this guy. All right, so now let's go ahead and let's combine like terms. So we've got 11x plus 2 equals 5x plus 68. Now move your variables. So what you're going to do is you subtract 5x. That cancels out. You'll get 6x. Subtract 2. That cancels out. And you've got 66. Divide both sides by 6. Bam, x equals 11. And that's all it's asking for is a value of x. So now you're going to do the same thing. This is your exterior angle, and these are your two remote interior or your two opposite interior. So go ahead, try this one. And then more triangle theorems. So this one is basically saying for an isosceles triangle, in any isosceles triangle, the angles across from the congruent side are also congruent. The sides across from the congruent angles are also congruent. So if you were to look here, if this side for an isosceles, these are both the same. So then this is across from here. So this guy and this is across from here and this guy. So your opposite sides are going to be the same angles because your sides are the same. All right, so here's the neat thing with equilateral triangles. A fancy term for that is also equiangular, with angular meaning angles. So if you have an equilateral triangle, all the angles are going to be 60 because 180 divided by 3 is 60 degrees. So equilateral, same sides, is all going to have the same angles also. So let's go ahead, let's try this one. We're going to do the first one where it says find the value of x and y. So we have to do two parts. So first we're going to find the value of x. Well, finding the value of x isn't too bad because we know this is 90 degrees. So to find the total amount, we could go 90 plus 65 plus x equals 180. And then you're going to get 155 plus x equals 180. Subtract that. X equals 25. So now that we know this is 25 degrees, now we can start figuring out the sides. So if you notice, this is a right triangle. So since this is a right triangle, you can use your Pythagorean theorem. Oops. Didn't mean to put the squares there, sorry. All right, so remember for Pythagorean theorem, since we need to find the lengths of the side, and then write your formula, plug in what you know, solve for what you don't. So we know that b is 4 squared. We know a is 3 squared. We do not know c. That's what we're looking for. Take the square root of both sides. Also, this is a Pythagorean triple, so you'll see that it's a 3, 4, 5 triangle. So that means y equals 5 because c is y. So for this, you just had to find a Pythagorean theorem because it gives you a right triangle, and then you had to find the angles, which is 180. Now let's go ahead, let's do this equilateral triangle. And in this case, we know that all the sides are the same, and the reason we know all the sides are the same is because all the angles are the same. So to do this, each angle is actually 60 degrees because 180 divided by 3 is 60 degrees. And so that means this side is equivalent to that side, which is equivalent to that side because opposite sides are the same. All right, so let's figure out what y is. So if we know that 5y is the same as 60, you can equal them. Divide both sides by 5. Y, done, check. Okay, next one, let's go ahead and let's look here where we need to find the lengths of our side. Well, we have no idea what this side is, but we do know this one and this one, and we know that they're equal to each other because it's equilateral. So we're going to actually combine our terms. So I've got 2x here. I'm going to add the 6 here. And then when you divide both sides, oops. Hold up. I think there's a, okay, divided by 2. I was looking at the answer key. I think the answer key might be wrong. Well, let me double check that. All right, double check my work for this, but I got 3x. Did I write something wrong? I wrote something wrong. Okay, my bad. I was like, wait a minute. This isn't what I had before. Here's my mistake. I forgot to make this a plus right here. That's why. Okay, so let's double check that. Let's go back. So now that's going to be 8. There we go. All right, much better. I did not write that correctly originally, so I had to double check my work because it wasn't matching up. All right, there we go, much better. X, boom, done. All right, so here's your hint here. You're going to do this one, but if this side is 4 and this side is 4, then that means this angle has to be congruent to that one. Okay, so that's your hint. You're going to try this problem. This one down here, this one looks crazy, but it's actually not that bad because if you notice, all the sides are equal to each other. So if all the sides are equal to each other, aren't all the angles also equal to each other? So let's go ahead, let's start, and let's find this. So if I know that this angle is 60, and I said all the angles are the same, well then y is equal to 60. And the same idea. If I know this side, oops. If I know this side is 4x, well this side has to be equal to 4x also. And then divide by 4, x equals 10. All right, there you go. So you're going to try these other ones. These are a little bit harder, but here's your hint. If this is an equilateral triangle, remember all your angles are going to be 60 degrees, and this whole thing will be 60 degrees. That's your hint. We know this is 90 degrees, this is 90 degrees, oops, and this line intersects, so it has to bisect. So here, if this is 60, the opposite side should be 60, 60, 60, so these guys should be the same. And then here, this whole thing should be the same as the other two lengths. So I marked it up for you. You're going to go ahead, you're going to finish this one. And then you're going to do the same thing for this one. So these are a little bit trickier, but you can do them. All right. And so remember, you've got your you've got triangle inequality. So to figure out if it's a triangle or not, you got to make sure you do the two smaller sides and it needs to be bigger than the larger side. And then you have the range, which is where you subtract the values to get the smallest it could be, and you add the values to get the largest and write it as a compound inequality. And then you go through exterior angle, the sum of the two remote interior equals the exterior angle. And then the isosceles, where the opposite sides or the opposite angles of the side can be congruent because the two sides are congruent. So that's your more triangle theorems.